Morning and welcome to Lunchtime BABLing. My name is Shea Brown. I'm the CEO of BABL AI, a company that audits algorithms for bias, ethical risk, and good governance. I'm very excited. Well, let me first say that I'm reporting from a different location than I normally report. This is spring break, and so as always with spring break, you've got family visiting, and so as opposed to my home office, I'm at the University of Iowa, my office there, and so that's my other half of my life, which is the physics and astrophysics, is up there. I'm very excited to welcome Jiahao here to talk about. Actually, I don't know what exactly we're going to talk about, but I know it's going to be interesting, at least for us, which is the primary concern, and then hopefully other people also find it interesting. Jiahao, thank you so much for joining me. Let me first ask you a little bit about yourself, like about your journey to responsible AI and data science in general.
Thank you so much for having me, Shay. So my name is Jiahao, and the guy in the back is Tank. So he's part of the crew here. I will try to give a very brief how I got here story. So my background is in computational physics. Got interested in making a transition into academic scientific computing in my postdoc. And in 2016, I saw the deep learning revolution mostly taking place outside of universities, and I thought that would be a good time to go experience it firsthand in a data science position. So I was a data scientist at Capital One, built models, and then realized that I wasn't doing deep learning. I was doing like the fairly basic regression, naive-based stuff that we teach graduate students at school. So I thought, well, why was the bait and switch? Like I felt like this was not what I signed up for. Digging into it, and probably familiar to theme that you and your listeners know very well, is that banking is just very heavily regulated. There are all sorts of requirements to make sure that developers are required to front load the evidence that their models are not discriminating, and they can explain the outcomes and decisions made based on algorithms to consumers. And what that means in banking is that if you get rejected for a credit card application, the bank can't just say, my model said so. It has to give you a reason that is materially related to the business. So something like you don't have enough credit history or you don't have enough income is a reason, and be able to demonstrate to regulators that that is actually how the model was reasoning about your particular credit risk in making that decision. So fast forward to in the future, I was director of AI research at JP Morgan. I continued working on what responsible AI meant in financial services, looking also at things beyond consumer banking, like looking at investments and like commercial bank related work. Worked on a company called Parity that was working on algorithmic audits for the upcoming New York City law. So that's how we connected, looking at the need for explainability from like an audit perspective for employment AI. And currently I'm an independent consultant. I work with several government agencies and startups on taking responsible AI into production and understanding how to connect the high-level risk management principles into actual operational requirements for day-to-day. Yeah, thank you very much for having us.
Oh, thank you. And it's a spooky level of overlap that we have, given that I also am a physicist and do astrophysics. But it's surprising. I feel like, and I don't know if this is if you feel this way too, but I feel like for some reason the way that physicists think about or parse out problems is actually quite useful for not just data science, which I think it is kind of a nice way of thinking from kind of first principles, and also thinking about causality, which is relevant and often missing in data science. But even for responsible AI, I feel like there are some advantages to having that sort of scientific approach where you always are questioning things. Not to say that other disciplines don't do this, but I do think that physicists often will default to that. Do you feel like that has been a benefit to you?
Yeah, definitely. So I I actually was a double major in chemistry and CS in my undergrad, and I decided to go towards sciences for my PhD because I felt that it was more interesting to me to think about like why were things the way they are rather than just doing computing for its own sake of computing. And you could argue that maybe that was not the best perspective on undergrad CS education, but that was certainly how I felt about things. I feel like the way I've learned to think as a physicist has really helped me in being productively skeptical about the work that I do and the work that I see that come in for review. So for example, one thing that has been very useful for me is thinking about asymptotic limits, which is something that, as you know, in physics, we are very accustomed to doing by saying that usually things simplify in like the infinite limit or like the zero limit or things like that. And so taking things to extremes and understanding how exactly does your model break, or maybe if it doesn't break, maybe it simplifies and reveals some new insight, like maybe some sort of hidden symmetry, maybe some sort of limiting behavior that actually has some sort of qualitative signature of what happens in a more practical setting.
Yeah, that's I mean, that's an interesting perspective. It's not always easy to think about asymptotic limits when you have a deep learning model, though, right? It's you have, well, I actually maybe dig a little bit deeper into that. If I have a model which is, let's say, ostensibly black box, and so you're dealing only without inputs and outputs, to do some sort of asymptotic analysis, would you essentially be looking at the extrema of the parameter space of the inputs and asking what happens if I turn this number up to 10 million or something like that?
Yeah, so I just maybe I'll make a plug that there is a little community of understanding the intersection of physics and machine learning that has done some really interesting work in this space. So I don't know if you've been following some of this work. I think the earliest version I know is called neural tangent kernels. And I think there's some stuff that I haven't been fully up to date with in that space, but they're really trying to understand things like, what if you took the infinite limit of construction of neural networks? What if they were infinitely broad and took infinitely many neurons? And what if each layer was infinitely wide and then also infinitely many layers? Like, what's the limiting behavior of that? And actually, there's been interesting work to say that in those limits, you can understand the behavior of a neural network as a stochastic differential equation. So there's like neural ODE stuff is basically working on that level of insight. I'm not sure what this exactly means for understanding behavior of neural networks in practice, but it's an example of the kind of, shall we say, cross-fertilization of taking a physics perspective on something and actually saying that here's something complicated that's very hard to analyze the usual way, but actually in the limiting case, things simplify, and there's actually things we can say about learning rates and generalizability that could feed back into what actually happens in practice. So that's one example of asymptotic thinking. But also just, we don't even have to go to neural networks to think about that, right? So just asking very basic questions like, will your model fail if there's only one data point in one of the classes? Or like if there were an infinite number of data points in each class. So just reasoning about things like, class imbalance in the extreme limit actually was a guiding principle for some of the research I've been doing in this space. So like, for example, when we talk about discrimination testing, it's often the case that by virtue of being a disadvantaged group, you're also sparse in the population, right? These two things tend to be very correlated in practice. And so just being able to ask very simple questions like, what does it mean for group disparity when there's maybe one or two people in that group in your sample data? And is actually the measurement of bias itself going to leak information about decisions made on your behalf? I think this is something that was a line of research that I pursued with Sangamitra Datta, who is a professor at University of Maryland. And this was an idea that was deliberately sparked by my thinking about what happens in this limit. Like, will something break? And discrimination testing happens to leak privacy in this aspect. Like, it's sort of like, when you say it out loud, it's like in retrospect obvious, but then why didn't people ask these questions before is sort of the meta level question that goes back to like thinking like a physicist and how that could be helpful.
Yeah, that's really interesting. Yeah, I think sometimes the best ideas are often the most obvious. in hindsight. People didn't notice them before, sort of hidden amongst the trees, so to speak. So speaking of complex models, let's move on to something that maybe you're tired of. I know I'm tired of hearing about it, but everybody's talking about it, which is these complex large language models. So ChatGPT as the sort of more famous example recently. And I think there's been a lot of talk about, it seems to be there's two camps, more than two camps probably, but there's two extreme camps. One in which this is extremely dangerous. We don't know anything about them. Lots of bad things are going to happen if we let them loose in the wild. And then there's another camp of people who think that they're very powerful and productive and are going to help society. And then within those camps, of course, there's different levels of your belief in the capabilities of these language models to actually be thinking in some way, or to abstract concepts in a way that might be similar to how humans do it. So I just want to given your expertise on some of these issues and your sort of focus on responsible AI as well, like, what are your thoughts about this current space that we're in with these large language models?
Let me start by saying that I'm seeing a lot of client interest in just understanding what is ChatGPT, how exactly does it work, and can it provide business value for me? And like on the surface of things, it looks like, well, here's the thing that is able to articulate, at least in writing, and possibly now in pictures as well, with GPT-4, like some sort of embedded reasoning that could be useful for maybe dealing with retail customers, or helping me draft prose that I need to write for a report or a paper or something like that. And I think there's very strong empirical evidence that these things are useful to the point where people are trying to commercialize them, right? Like if you look at the most recent batch of startups incubated through Y Combinator, like I think the statistic I saw was like over 125 startups have pivoted towards building on top of ChatGPT or building on top of LLMs in general. And we're seeing everything from paralegal services to sort of like resume screening tools to customer service chatbots being built. And like we're seeing a new gold rush of development in this area. So from a commercial perspective, there's enormous interest. Now, the question that I think is really interesting is that is it working, right? So and is it working necessitates a very critical look on like how does it work. And I think this is where, like, we see people in the responsible AI space say that, look, like this thing is just a Markov chain, it's just spitting out tokens, it doesn't understand what it's saying, because that's the underlying generating equation is literally just like a Markov chain of things, and then you just train it on data, and that's all it's doing. So that's definitely true, literally, but it doesn't fully explain the problem, right? And it's missing this notion of emergence that we know happens in statistical physics, right? So the criticism that LLMs are just stochastic parrots and that they're just like Markov chains of tokens being emitted is true at a very basic level, but it's also true that us as human beings, like we're literally just a collection of atoms that can be described by Schrodinger's equation, or like, some sort of like, statistical mechanics, like, equation of motion. That's true at the microscopic level, but those equations somehow embed and describe systems like us, like the two of us talking today, having lunch, doesn't explain how chemistry emerges from physics, doesn't explain how biology emerges from both chemistry and physics. And I think that's the missing gap in that kind of logic, right? But we're seeing it in a much more abstract area. So understanding, like, is there actual intelligence or dimensions of intelligence that are practically useful, emerging from something whose baseline behavior is this kind of random generation?
I have a similar way of thinking about this. I feel like a lot of the criticism. So, I mean, I think both you and I will agree that there are some practical worries about the implementation of this sort of ad hoc in the wild, in high-risk areas. However, a lot of the criticisms do seem to focus on the fact that it doesn't know what it's doing, or it can't make logical inferences because of the statistical nature of the models. but I find that a really weak argument, because I think I mean, you don't even have to go to humans to think about this. You could just look at things like word embeddings that encode logical relations between objects, like man is to woman as king is to queen, or something like that. These things get embedded through the data. It's encoded in the data in our language, and a lot of our intelligence is encoded in our language. And so I feel like there is a lot of logic that's happening as an emergent property. Now, I also agree. I think it's more important that it's not tied to anything real, and there's no real policy. If this were tied with reinforcement learning or something, where it could meaningfully react to its environment based on its sort of baseline level, or interactions with other humans, like, did I make this human happy? Did I make it sad, or something like that? So there is a long way to go, but I think I do agree that there's this emergent logic, which is not dissimilar from what a child does when they're repeating what their parents say. But then again, I think there are a lot of worries about how people actually use the models, but it's not this that's the real worry. It's not that it's not thinking. That's really not the problem. But so what's the ultimate limit? Like, where do we go with these? So let's say, what are the current limitations? Let's focus on the current limitations, right? Because they're clearly not perfect. So let's say I'm a business person thinking about listening to this, and I'm thinking about, oh, I want to use this in my business workflow somehow. I'm going to automate something in my workflow. It could be reviewing documentation. It could be interacting with clients or customers. What would you highlight as the kind of key steps to figuring out whether it's going to work for your use case or it's not going to work?
Absolutely. So let's take like the retail facing chatbot as an example, right? So I think there are lots of questions here about intended use and purpose. So, why do you want a chatbot, right? Do you have a scale problem with your customer service business? And if so, like, is this a problem that could be solved without AI? I think is always the starting point. Like, why do you want this, right? And like that helps people kind of crystallize around whether or not they have a genuine scale problem that they're trying to automate, and AI is one way to automate that, or if they are like doing more of an exploratory thing with emerging technologies and say, like, here's up and coming, I want to understand what's going on. Or like, if there's maybe some herd mentality latent in that, to say like, well, everyone's doing it, I better like, throw my chip in the pot and try to figure out if that's also something I want to get involved in. So let's assume that like this is actually a genuine scale problem, and the customer genuinely needs or wants a solution, and there's actual potential value here. Then the next question is how do we make sure that it is what does success look like? Is the next question, right? So success, and probably in the consulting space you're familiar, like oftentimes that's an iterative and extended discussion process with the client, and it's very rare that a client knows upfront from day one, like, I know exactly what it means for this to be successful. And so there's a co-design aspect of it to say that, what about this? Maybe it's not this, maybe it's that, maybe it's not that. And that discussion often looks like, I want this thing to make my customers happy. Okay, what does make your customers happy mean? It means things like, oh, I want to be able to automate simple things like inquiries about where my shipment is, like what's your refund policy, like I got the wrong product, it was defective, things like that. Like just even being able to work with a client like that and understand, like, these are the questions that actually come up often. Some of these are easy and automatable without AI. So like, where's my shipment? Okay, well, this clearly means like you need to build a connector to like FedEx or DHL tracking or something like that, and that you have an answer. You don't need AI for that, right? And you would not ask GPT-4 to answer that question, because this is real-time data and a very, very specific question, and that's not the right use case for generative AI. But if it was explaining something that's fixed, like understanding what is my store return policy, You could also argue that that's not necessarily like a thing that requires AI, because literally you prepare the policy and it's written on the website and you can go read it. I think what starts to become interesting is if there's like a question and answer aspect on top of this. So suppose a customer reads this and they have a question about your policy, and so take, for example, privacy policies or like end user license agreements. Like, I think we all have seen like many such things put in front of us just to use software. And most of the time we just go like, okay, it looks reasonable, click, or like half the time we don't even read it, we just click, right? Like there's a famous South Park episode about what happens when you don't do that. And this is starting to get into a question of like natural text understanding. Like, here's the policy, what are the edge cases? Does this come up in my situation? Is what parts of the policy are applicable? And this tends to be something that comes up for the clients that I see from like the insurance space. So oftentimes people buy insurance policies and they're like, okay, I'm covered. And then the bad event happens, and then they go file a claim, and then the claim is turned down because it's not covered. And then people get upset. And so you could argue like, what's the problem here, right? So the problem here is you bought something that you don't fully understand, or you bought something that didn't actually deliver on what it is that you thought you would need. And could a chatbot like that is possibly powered by ChatGPT help you through that kind of reasoning question, right? So that becomes like a much more interesting question. But also now you start to see the issues here, right? Like, you cannot afford to have the chatbot give the customer the wrong answer, right? And how do you now guarantee that a generative AI will not say the wrong answer to a client and misrepresent like what you're offering to the customer? Now becomes a really like nitty-gritty problem. It's like, okay, if you want to use this, we need to use this with guardrails, we need to implement some sort of verification. How exactly to do that is, as you know, like an area of active research, and that kind of is where people are starting to converge to.
Yeah, definitely understanding whether in your use case getting something wrong is risky or not, or what level of risk that is for you, seems like a pretty important. But I like starting with the why. Like, why are you even using AI? I think that's a good gut check as to whether this is just a fad, or you're excited to jump on a bandwagon, or whether there's actual business value that you can get out of that. What are your thoughts on this area of research? Like, because for me, like I'm playing around with the idea of launching into this, because I think that there are areas, like it feels like an area of responsible AI now. It feels like this because these large language models aren't going anywhere. They're gonna get used, and they're gonna increasingly get used in more high risk situations. And so it does seem kind of imperative. Like, I know for a fact we're going to have to audit some of them, right? And we haven't yet. We've done, 5 years ago, we audited sort of like sentiment analysis systems and things like this, which were much easier. But when you have a large language model, the parameter space of both the prompts and the outputs is infinite, and it's and you need to really abstract a lot of that away into sort of domains and domain-specific areas. What do you think is the kind of most fruitful way that you see for people to put guardrails? Like, is it hard logic? Is it training another model to recognize when there are dangerous areas that are going to trigger a human, or trigger some sort of template response? Like, do you have any insights into this?
Based on what we know today about the behavior of large language models, like there are definitely ways to improve the output of LLMs using prompt engineering. So I think some of the most famous ones are like chain of thought. So asking an LLM to answer a question, but also to say like, show your work, or like also like explain your reasoning behind what's going on, like variations on that. It actually improves the output of what is called the zero-shot limit. So it's literally like the first answer that comes out of the LLM, like that, like the improvement like on benchmarks, like goes from like, in some cases like low single percentage points to like 70 or 80%. So there are very real ways that you could manipulate the input fed into the LLM to try to improve the quality. And the other thing that also helped is also just asking like, is this answer correct? as like the follow-up question, and asking the LLM to self-evaluate actually also is amazingly effective. And we don't fully understand why it works, but empirically it's been shown that this is another way to improve quality. Now, so, but we're talking about like improvements from like maybe like 60, 70% to like maybe 70, 80%. Like this is not going to be good enough for a use case where, let's say helping customers understand their insurance policy type of thing, where like your error rate has to be literally like less than 1 in a million or something like that, like your overall process. And so if you take something that is like has a 15% error rate in saying the wrong thing, how do you turn that down to like the Six Sigma level of like not saying the wrong thing? Then like you have to think about what exactly that means, and like putting in place like what kind of reviews happen, and maybe you have to start thinking about fine-tuning not just the output of the LLM, but maybe like whatever guardrails that you put on top of it. So maybe adversarially built training a model, like you said, could be helpful, or just saying that like maybe you could imagine like, with the fine-tuning aspect, just saying like, I maintain an active database of things that the chatbot has misrepresented or misspoke in the past in my testing, and make sure that you test those cases, and just say like, no, your answer was previously rated to be wrong, like fix it. Like, does that actually help? So starting to think about the engineering and feedback process, I think is really important there.
Yeah, I think I'll be excited to see the research as it comes out, and some of the teams that like are implemented in Bing, and to see what they've been working on. I don't know, has any of that been released? Any kind of, I'm guessing it's all proprietary, but I feel like that will be really fruitful experience that team is getting, trying to put up guardrails and interacting with it, and keeping logs and trying to understand its behavior at a really fine-grained level. Is any of that out yet?
Yes and no, right? So I think there's there's Llama, for example, from Facebook, that is open source for some very loose definition of open source, right? So if you're an academic researcher, you've passed the approval process, you can get the weights, you can analyze them yourselves, and that's like one extreme where like you have full access to the model, you can do anything you want to it. And then you have the other extreme, which is like the Bing and OpenAI model, which is like everything is paywalled, and like you have to, like, you can only access it through like the approved APIs, whether or not it's through the browser or through like some programmatic thing, and they have full control over what exactly comes out. So we can understand like the very good trust and safety reasons why a company might decide that that's the way they want to release their software, because they're afraid of toxicity and all of that stuff, which is like, you could debate about whether or not that's a good idea. But what this highlights as an auditing challenge is like the difference between white box and black box access. When you know everything, like you literally have the model weights and code in front of you, you can do much more in-depth testing and analysis than if you're restricted to the black box case. And I think what we're seeing now is people reacting to the fact that they're used to a white box evaluation and examination paradigm where everything is available. I get to see everything. And now we have literally just seen in the past week several major improvements that were black box in nature. Like, you can't poke apart my model. All you can do is test in a black box way. And so in this sense, the narrative has to shift towards something that's more along the lines of what people have been thinking in like the cybersecurity and privacy space, where like, I don't know what the attacker could do. Like, the attacker literally could do anything. And like, how can I prevent that bad things from happening anyway is one of the useful framings of how people in those fields think about the work that they do.
In some sense, so let's say I have access to the code. Explain to me what are extra white, so for something like a large language model, what are the extra things I could do in white box testing that I couldn't do? So presumably if I had to test, let's say for regulatory reasons. So I'm an auditor, and the European Union says you have to test this large language model, and you have unlimited access to its API. But then I have the code in front of me, the code of which is fairly simple for a lot of these, simple in quotes, right? It's simple in the sense that the underlying sort of transformer model is fairly standard, and then there's clearly going to be the logic around it for whatever the guardrails are. What do you see as the advantage of having the access to the code itself?
Yeah, I think the main thing is actually not the access to the code, because as you said, like, most of these deep learning networks, like the actual arithmetic they're doing is very straightforward. And we've already discussed in the beginning that, like, that's like the microscopic detailed version. It's not really explaining like the more complicated phenomena that are emergent that we're really interested in. And that emergence comes from the data. And so that really is a question about understanding things like distributional shift, like is the use case that I have, like data that I intend to feed through the model, how similar is it to the training data that was fed in? And even if you don't have access to the training data, at least you have access to some encoding of it, which is actually what the model is going to do any sort of like emergent behavior on. And being able to probe that and do things like the bias test that you mentioned, right? So, like there's a very famous paper that's almost a decade old at this point. It's like asking, like, man is to programmer as woman is to blank, and like, ask it to do these kinds of semantic associations to test for bias. And, that's something you can do in a black box way, of course. But now you can ask, like, what is the white box like thing I can do on top of that, and just understand, like, how was that fed and activated and like sort of like transformed through the data, and like just being able to understand like things like attribution, right? Like if like that's maybe another good example is how, like, on what basis did you arrive at this, right? So there's attribution methods that look at like feature importance, which is like one end of the scale, but there's also like what in your training data looked most similar to this that made you output something that looked like that.
Yeah,
it's a really useful kind of explainability that tends to resonate more with business clients, quite frankly, because they like to hear things like, well, we approved this customer for the mortgage because it looks like customers we previously approved, and these were the characteristics that we thought were good in the old customers. These are the and this customer has those characteristics, right? So like it's a very natural encoding of what we intuitively think is like approval based on prior experience. And so we're asking now the very sophisticated LLM version of, based on your prior experience, what you've been trained on, like, what are you going to say in response to this question? Is that you can now start to try to trace through and understand in the latent embedding space, like, what are the things that you have learned as concepts, even if those concepts are not necessarily things that humans can recognize, but at least understand what's being activated. And are there maybe things that could be triggered that pose risk around that in the local neighborhood, are questions that we can start asking around robustness and safety.
So I think getting some handle on the training data would be, because that's one of the things that when I'm looking at a system that I worry the most about is the relationship between how it was trained and on what it was trained and where it's being deployed, and understanding. And of course, I think you can't require those to be the same distribution, right? It's almost impossible, and I think most humans don't interact in ways in which we abstract to new situations quite well. But having some access to that distribution of the training data, and to what extent it did well in different parts of that parameter space in terms of how precise it is, and potentially how biased it is, and that sort of thing, is a kind of a great handle on potential risk, even if a lot of it is qualitative in some way. I mean, you can get quantitative, but it's not perfectly quantitative in terms of the use case, but it's a qualitative look at the quantitative data and those distributions to get a sense of, oh, this might be a risky part of the parameter space to use it in.
And just to add on to that, like, I think the AI world has come full circle on, previously thinking like, oh, AI is going to be powerful enough to like, generalize far beyond the data, and then going, no, actually, like there are large aspects of AI that are literally glorified curve fitting, and we need to understand like the data provenance, the data origins, and understanding all of those things. So very mundane things like how clean is my data, where did it come from, is there survey bias, is there incompleteness in the way I source the data, are there copyright licensing issues, like all the things that people have not really thought about very hard in this space because it was primarily research based, and like researchers more or less like get a free pass for doing things like this. But now when we're trying to commercialize things, we need to be much more rigorous about, are we using data that's appropriately licensed, that is sufficiently representative that we can try to generalize this? And are there potential like biases that are encoded in just the way we source the data? So one example that comes to mind is like the Whisper model from OpenAI, like features multilingual translation and transcription, not just in high resource languages like English and French and Chinese, but also in like these indigenous languages. But indigenous languages, like they have they're owned by peoples who have very different ideas of data sovereignty, like basically that cultural heritage is theirs and theirs alone. And there are open questions about whether or not a company like OpenAI just like happily just scraped an entire data set of like an indigenous website that was not meant for commercial purposes, it was meant for research purposes. And now that has shifted, but it's now part of the model. Well, then what do you do in these kinds of situations? So these are very real active questions about like making sure that people who are providing the data are empowered to say something about how that data is being used.
Yeah, I mean, this seems to be I mean, since GDPR, this has been kind of forefront of a lot of people's minds, exactly what right do I have over my own data? You know, do I own it? Or do I have some say in how it gets used, despite checking the little box that I didn't read? And also the inferences that are made about me. That's another thing which I think has gotten pushed back. One of the things that these large language models has sort of pushed to the side is some of those kind of questions that were really in the forefront, and now people are sort of tackling this new demon that has risen. But issues about just ordinary machine learning, which is getting used a lot now, just classification and regression models that are being used in many products, and are because they're easy, and I feel like they're getting used a lot more, and everybody's now currently focused on these really complex large language models, and there's still so many of this sort of glorified curve fitting, which we know for a fact can produce bias outcomes very easily, especially when you have class imbalance. And so I'm hoping that it doesn't distract too much from, like, I'm hoping a lot of the smart people who were focused on sort of algorithmic discrimination are not going to get sucked into these debates around large language models too much, because we need those smart people to protect the rights of those who are, you know, getting these algorithms used against them.
No, so at least the way I think about it now is that for better or worse, like the post-ChatGPT era is forcing us to even redefine what responsibility means, right? So there, if you look at how companies and universities have defined these research agendas previously, it was very much focused around like technical aspects, things like algorithmic fairness or like explainability or privacy. And now, like, all of these things suddenly became interrelated, right? And then not only that, it's also things like data management, data quality, and then now also like things like psychometrics, like how do we evaluate like, fluffy, ill-defined concepts that are things like intelligence or like, toxicity, and like, are the benchmarks that people have for these currently, are they good enough? Were they developed, like, things like, passing the bar exam, like that was a test designed for humans. Like, are you making some sort of epistemic assumptions when you translate that validity into like assessing like if something like ChatGPT could be a good lawyer, right? So that we start to see like a lot of broadening of scope that is necessary because of the increasing generality of what is being claimed right now.
It's good that those things are being reflected on, because I think a lot of those types of assessments of human intelligence are so fraught, or have been so fraught. And I think, and there's been a lot of criticism in certain groups of those anyway. Like if you talk to the academic crowds or people who do critical theory of different types, they would have they've been railing against those sorts of things for a long time anyway. But now you're right, it's kind of bringing it to the surface and hopefully calling into question exactly what we think we're measuring with some of those assessments on humans, because now we have to tackle the fact that we have large language models that can actually pass those exams. And so is it really intelligence that we're measuring? And in some sense, so I'm trying to wrap my mind around this is on the fly now. So I'm trying to wrap my mind around exactly what the new question. So you might have the bar exam, which says, okay, I have some reasonable assurance that this person who passed the bar exam could practice law in a particular state or something. And now I have this large language model that does the same thing. And so what is it about the human or the human's capabilities or my trust in that human? Is it the fact that I know that they will learn on the job? Is it the fact that I know that they're going to enter a law firm or a partnership that will have some oversight or guidance? Or is it that I simply trust humans more than the machines? I'm wondering what's your sort of gut reaction to what the main issue here is?
I feel like this is like a question for more like a different aspect of our work, which is like the educational psychology of things, right? So like, as educators, like how do we assess student learning? And if you go way back in history, right? So like, oral histories were very much a thing, and feats of rote memorization were a thing, and like there's like ample history of things like imperial China relying on like memorization of Chinese classics as like some sort of yardstick for merit, that like if you could memorize like all the writings of Confucius and whoever, that this was therefore what made you worthy to serve the emperor, right?
Yep.
And you fast forward into like even like 100 or 200 years ago, when like you look at like the era of mass education and now like testing to ensure that educational outcomes were being achieved, like what exactly did that mean? And it meant things like, okay, like trying to standardize around curricula and testing rubrics and things like that. And so to me, that question you just asked is really a question of like, what is the appropriate rubric to ask a non-human intelligence, or something that's suspected to be a non-human intelligence, right? So if they're reflections of ourselves, and if they're sufficiently like a reflection of ourselves, then it would look like they would be doing the things that we thought were hard. But these things are fundamentally built with capacities that we don't have, right? Like they're literally built to be eidetic. Like they're meant to recall and memorize vast amounts of information, far beyond what any one human can do. That's no longer a good yardstick. And if you think about like sort of like the educational testing like hierarchy of like, well, first let's test the students' recall, then test like critical reasoning and synthesis and that kind of thing. Like, yeah, recall is like sort of the baseline. Like we all know that these things are very good at memorizing, but it's failing at very basic things on the next level, which is like understanding critical reasoning skills. Like there was a Twitter thread I read like just 2 days ago that like it's pretty good at addition. Like ChatGPT is pretty good at addition and like fairly good at multiplication, and it is really crappy at division. Yeah. And like it just breaks based on what numbers you feed into it. And so like there's clearly something wrong that's going on there, right? And that is a brittleness that is new and unexpected, that we don't expect in humans, but we're seeing it happen over and over again, right? So just to mention one last thing, which is like, looking like at AlphaGo and like how AlphaGo beat Lee Sedol, who is like the human world champion of Go. And then AlphaGo was defeated recently by an amateur ranked player who actually managed to learn exploits and weaknesses in the strategy that people didn't realize. So like that non-monotonicity is like, I think, a big implicit assumption that we need to call out in testing.
So in some sense, we need like a Bloom's taxonomy, but for artificial intelligence, where we got to find that right axis where it's going to have a monotonic improvement along that axis and not necessarily along our axis.
Right.
Yeah, that's interesting. I think I'm hoping that it calls into question, and I think it is anyway, because of the fact that writing is becoming something that can be automated in some way. like I hope it does call into question the way we educate and the way we assess, because I mean, I teach at a higher education at a university, but in a lot of ways I feel like we need to rethink how we do education in our society. I think there's there are a lot of barriers, and we're just not testing for the right things, and we're entering a world where it's not we're going to ask different things of people than what we're currently asking of them, and a lot of it centers around being good people and being social and being creative in ways that only humans can be creative and things like this. So I'm excited about the future, but terrified at the same time, and I'm hoping that this sort of allows us to question some of the fundamental assumptions that we've had in higher education. Well, not higher education, period. So we're running short on time. I want to ask one more time if people have questions, but I want to switch a little bit into auditing, because that's something that I don't often talk to a fellow algorithmic auditor. And so I just want to get your thoughts on the current landscape of algorithmic auditing, because, and you know, you're very involved. You've commented on New York City laws. You've worked with companies around New York City Local Law 144, but you know, there's the Algorithmic Accountability Act, which may or may not get passed. There's a bunch of state laws in the EU. There's the AI Act, and then probably more importantly, the DSA for these large platforms, which is calling very specifically for auditing. And so, you know, now's the time kind of for our community to ask ourselves, like, what do we think auditing is, and how can we best serve these upcoming legislation and law, and how do we inform policy? How do we help them, policymakers, understand what is the right level for auditing? So anyway, I just want to open it up to your thoughts on where we're at this moment in algorithm auditing.
I feel like we could easily take another whole session on this.
I think maybe we should also, yeah, we'll do a short version now, and maybe we'll come back in a few weeks and have a longer one.
Yeah, so I think the first question to ask is, like, what is actually needed? What's the reasonable minimum amount of effort necessary to be compliant? And this is unfortunately a problem that keeps getting raised over and over again, and regulators don't have good answers to it. And I think it shows a fundamental philosophical difference between what business people want and what regulators want, right? So business people want to be told, if I need to be compliant, tell me what to do to be compliant, and then we can move on. Regulators and lawyers, on the other hand, like they tend to be more of the do anything you want as long as it's not illegal side of things, and then we tell you, like, here are the guardrails of, like, this is what constitutes bad behavior. And we're seeing a failure of this kind of epistemic gap, or maybe epistemic is the wrong word, but like sort of like this sort of like worldview gap, shall we say, because when we talk about things like, you know, like compliance for you know, the New York City law, and understanding, like, what is exactly employment discrimination's requirements for testing, and then you've heard this trope being pulled out over and over again about, oh, like, well, we have the 4/5 rule, just compute the 4/5 rule, then we're good. But then that's really not really what the law says. Like, that's actually like a very bad misinterpretation of what exactly the requirements are. But we can also understand from an intellectual perspective why that's such a persistent myth, because it's one of the few places in employment law that looks normative. It looks like it's saying, do this and then you'll be compliant. And that's the clarity that people want. I think the US regulators are very hesitant to do that, because they tend to place a very high priority on not stifling business innovation. And that's why they tend to be much more open-ended. And in contrast, if you look across the ocean to Europe, they're much more willing to be normative, and you know, I've been speaking to some of the regulators there, and they're interested to break down regulation in terms of should, would, and could, right? So like there are certain things you must not do, or there's certain things you must do. But then also going that extra step of saying, we're willing to put our necks out here and say, if you need help on what you should do to be compliant, here's our recommended best practice, which is non-binding, but it's kind of reflective of how we think about things. And I think that's the kind of discussion that I don't know if it's going to be politically feasible in the US, but that's a different model that I think starts to address some of these sort of gaps in requirements and like sort of on both sides of the regulatory relationship.
There's an open question as to whether in this ecosystem, whether auditing itself, external auditing, so some people call it third party, some people call it second party, depends on who you're talking to, but an independent auditor who is not in your organization, who you pay, but they have independence rules, think financial auditing, come in and actually assess the work that you've done or assess your models or your risk management or what have you. I think it's still an open question whether that's going to be part of this regulatory ecosystem. Even in the US, I mean, I think people in New York are pushing against it, even with this law, which is supposedly coming into effect in 6 weeks or so. And what do you think are the chances that, and I think the DSA is requiring it, but they still don't know yet. There are still robust conversations around what that actually means and what it looks like. And so what are your thoughts on auditing as an effective way of managing compliance? Is it effective? Is it something that we should strive for? Or should we start thinking a little bit more about best practices and just some looser kind of soft law requirements as opposed to this really heavy-handed auditing?
So let me start with platitude, which is that prevention is better than cure, right? So in an ideal universe, like auditing would have no function because there's nothing to audit. Okay, so having said that, again, this is an asymptotic limit of moral behavior. Like we're never there. Like 100+ years of financial history has shown that like you cannot trust institutions to do the right thing. Like even with the best intentions, even if you think you're doing the right thing, you could have unexpected consequences. And in fact, this is the entire genesis of an entire theory of indirect discrimination or disparate impact. And so it is not enough to just say that we have best practices and we're adhering to them. We still need to be able to test if there are unintended consequences. And unintended consequences still result in societal harm. It's going to result in people not being able to be housed. It's still going to prevent people from receiving the public services that they need and so on. So like there's no question that auditing is important. And in fact, the history of financial auditing shows us that it is important to have auditors both within the fence of the company and also on the outside to double check the work. Like that, actually 2 layers of auditing is essential. So you need people on the inside who are willing to support the cause of auditing and like being honest about what's actually happening. And then people who are checking that feedback as well. So like we don't need to go beyond like Enron or any of these other like big corporate scandals to know that that's a huge problem in practice. And there's always this conflict of interest that comes up as auditors. And like how can we be intellectually honest and reveal the dirty laundry if we find dirty laundry, versus how do we protect the client's interests to at least give them the chance to make a good faith effort to fix the problems before we air them. And I think this is a problem that becomes very tricky, especially when in a paid relationship, right? If you're a professional and you're paid by a client, like you have an obligation to the client to protect their interests. But at this, so we're starting to see here, like, like sort of a fork in the road, as it were. Like, will we see like auditors have like double down and be like, we're neutral, even though you hire us, we need to be in a part of the company that has no obligations to anyone except like the direct, like highest level of governance, like the board or the CEO, for example, because that's what happens in banks. Like, so audit sits within banks, but audit does not report to anyone on the business side. They only report up to like the head of legal, the CEO, or basically someone at the C-suite who can represent that. So that's one direction of things. And then the other direction of things is saying that like, no, we are professionals, that we get hired, and maybe that creates some analog of fiduciary interest to say that Yes, we are meant to help them fix problems as they arise, or at least be able to diagnose and say, like, here's your scorecard, here are the problems, and this is something that you need to escalate and fix. And so that is a different model where you could imagine that is actually something that we could be contracted to do under the envelope of attorney-client privilege. So the company's lawyers would hire us, not necessarily like directly by the company now, but to say, like, we want to hire you and fix things and tell us what we need to fix. And we have the legal protection with representation by a lawyer if it's necessary. And then there's yet another example of auditing, which is like, we are hired by a government agency and we are here to protect the public interest, and it's all systems go, like, we will like tear down corporate silos to get the data that you need, and we will have no restrictions and qualms about naming and shaming. But that's a different universe. That is actually a universe where, like, government agencies have the budget to hire auditors as part of enforcement. And that's very, very expensive. And we're not seeing it outside of very limited scopes, even in finance.
There are so many different shades of how this could be done in terms of the various axes that we could look at, things like the axis of independence, the axis of access to the data, the access to, like, is it attestation where the company does everything and you're testing it, like sort of like financial auditing, or is it direct access where you directly are going to access the algorithms, for instance, and do the testing yourself? So it's really the Wild West right now, which is worrisome for me. I mean, we both own companies that do this kind of work, and it's nerve-wracking because the standards are not there, and so we have to make decisions and certain choices that we hope are going to be in line with what it turns out is going to be the standard norm, or else we're putting our necks out there. And so it will be an interesting few years, I think, as the DSA kicks in and New York City kicks in and California and New Jersey and other jurisdictions that are attempting this sort of experiment to on algorithmic auditing and actually trying to implement it as an effective governance mechanism. Thank you so much for coming by. I definitely going to have you back again, because I think there's way more that we didn't cover that I'd love to cover. And hopefully people enjoyed listening to it as well. If you're watching this on YouTube, feel free to like and subscribe if you'd like. And if this is a podcast, then thank you for listening and have a good day.